All right, okay. So we go back to where we were, and then please, are you following? If I'm moving fast, you draw my attention. So we go back to the crank, then you click over here. So you can use this same process if you do not have internet. Let's say you have your PC at home, but you have internet somewhere, so you want to get the package, and then when you go home, you install. You can use the same principle. You download the tar.gs file, and then when you get home, you install it, just like you have a program on a pen drive and you want to install it on your laptop. Okay. So, yes, if we are here, you see the last one is what? 204. So it started in 204. So we have to go down. You see, so they were maintaining it from 204, 205. Maybe the person has died. And then nobody took it. So you see, it's been maintained until 2020. So after 2 years, if you are not maintaining it anymore, then they just archive it. So in this case, we'll go for the latest one. Okay, so that's the last one. So the 5. So you click on it. Once you click on it, what happens? It's downloaded. It's not that big, so it's there. Okay, so this is in my download folder now. Is everybody okay? All right. So the next thing is that we are going to R, and we want to install it. Okay, so let's go to R. So here, we will still go through the same process. We'll say install, but this package is not at the CRAN, isn't it? So we won't get it there. So what do? We click over here. It says package archive file. So that's how the archive files are installed. So we click on this, and it opens up the folder on our laptop. So we need to go to downloads, and then that's the Zilliq file. So you double click on it, and then you install it. Yes. Yeah. And then there it is. So is everybody okay? If you are not, you let us. This is an error in. So go back and read those. Okay, you are using Mac. Please go to question 1. have you been able to install yours?
It's giving you the same.
It's the same, yeah, sometimes. It may not install, so let me see. 0 where are you putting it? The same. You also have the same. In your case, the dependencies in our explained. There's a problem that, okay, let me.
So try it yourself, yes.
I have it already.
There's the one balance.
There's a what? Yes. Okay. So, you see, I said that it's so easy to do packages, right? Or to write packages. So what happens is that if you are writing a package, you always do it such that it depends on other ones. If somebody has done it, you borrow from there. Okay, so most of you would have seen AER. It is telling you that there are some packages, right? Yeah. Good, okay. So it means that for you to be able to install this, you must install all those packages before. Okay, so how do you do it? Well, when you say install packages, it says separate multiple with space or comma. So if we want to do this, I'll let you do it at home, otherwise we waste our time. What you need to do is that okay, let me try. I have it already. You need to copy whatever you have over there and then maybe put it in, what do we call it? Oh, you see, mine is working because I already have all those packages that Zelig needs in it already. So you have to copy all of them. It's on over there, right? Go up. You did it at first. So you go back to R. So cancel this. Okay. So it is telling you that you need this. So cancel this one. L. Cancel it. No, this. Yeah, so cancel it. Okay. So all these ones, you need to match it, but all these are packages that Zelig depends on. So you need to copy all these, remove all the what do you call it? The quotation mark from it. So you can do this in Word. You copy, then all the quotation marks, you replace it with nothing, right? And then you need to bring comma or what do you call it? I think it's comma or semicolon between each of the packages so that you install all of them. But they are many, so it may take time. And once it is doing that, it will, depending on the internet connection, it may take a bit longer. So you see mine is done now. So if you understand that, we can leave that so that when you have time, you do it so that we can move on. Please, is everybody okay? What I mean is this. Look at this. When you want to do it, when you want to install, mine did install. Let me see if I type this and it will come. Okay, so you see, undefined. Yeah, so these are some of the things that leads them to take it out from. So now you see there's this subclass that is undefined. So it means that the authors should have now done this, rectify it. They didn't, so they will just take it out from there. But it doesn't mean that the package will not work. It works. And one of my info students used it for what we did was to use this to predict whether an applicant for work permit will be granted or not. Okay. But in this case, this package is for the case where only, they said that in Ghana, when you apply for the work permit, surely almost a certainty you will be granted. Okay. Now, but in some cases, they will decline. Okay, so if you take, let's say, in a year, there were, let's say, 100,000 applications, you have maybe 4 who were not granted. We call that rare. If 100,000 and you have only 4, that's a rare case, okay? So in that case, what I mentioned earlier about logistic regression do not really work well, because that one assumes that you have almost equal number of people that were granted and equal, the other were not granted, something like that. Okay. So these are some of the things that later on, once you are getting through to talk about regression and so forth, we will get back to it. But this is to help us to implement those kind of things. Okay. So we use this package in the case where you have binary cases. So for example, the loan scenario, most people that come for it pay. Then once a while you have someone not paying. Is that okay? So then that becomes a rare case. And if you want to predict that, you can't be using the usual thing we use. You need something like this. And that's what this package was about. Okay. And remember that you will be doing some projects at the end of the course. These are some of the things you can. So maybe at your workplace, if you have some problem in classifying people into 2 different categories, but sometimes, most of the time, all the people are here. Once a while, this one comes here. Then these are some of the things you can apply, which is binary rare events. That's how we call them. But of course, you can have multiple categories as well. There's also multi-category classifications as well. Okay. So what is it that I'm saying? That you have a series. Can you give me some of the packages so that I know that when you go home you can do it? So what I'm saying is that there are packages that will be displayed on your R, right? The console. So for example, the first one was what? AER, isn't it?
Yes.
Okay. What I need you to do is to find it like this. AER. The next one is what? Is it the one that they selling? It's like this, right? Okay. And then the next one. Coda. Is it small letter? Okay. So these are all case sensitive. Okay. So what you need to list all these, then you copy them, right? So assuming there were only 3, this is what I'll do. I'll just copy them. Then I go to R, and then I go to install. But now I'll go to CRAN, right? Okay, and then I put them here. So now I can install all this at a go. So you see, it is telling me that these packages are already in there. So if I do it, it means some of them are currently loaded. I need to just override them. Yeah, so that's what I said you should do for all of them. Once you install that, and then you will be able to now install the Silic package. Please, is everybody okay with it? It is installing. Yeah. Good. Yeah. So that's how. So please take note of this. As I said, once you start using some packages, you may want to use them. But if the maintainer has died or if the person is not interested in updating it, it will be taken off the ground. And every day, packages are being taken off to the archives, and others are being added up as well. New packages. Okay. And I can ask you in your practical exams to demonstrate how you can install a package that has been archived. So I am telling you what I'll ask you. So when I ask you, there should be no surprises. Okay. Any question on this? Yes.
Would you give us some of the commands to use to work on the daily package?
So if you are interested in the case that I described, okay, then you can start reading towards it. So let's say you want to write your project on that classification where you have to group, let's say, people, or it could be animals, or it could be products into defective and non-defective. But this can be influenced, it has something that depends on this. So the product becoming defective may depend on, let's say, an operator not putting in the required amount of maybe a chemical, or the time that the product was supposed to be put on a shelf, or something like that. So if you are interested in that, then you can now start reading around it. So we will be talking about packages as we move on, different packages. So if you are interested in working on something like that, then you start reading around it and start using it. So that by the time we get to the second semester, close to the second semester, you already have your topic ready, so that you don't wait too long. Otherwise, it will affect your graduation. A package that has been archived. That's it. And that is what I said I can ask you. Because it's very important. Other than that, the package is not there. The package, meanwhile, it is there. Just that it is not at the CRAN where you can install it straight away. Okay. Any questions so far? All right. Okay. Then I'll move on. The last time I said I was going to talk about data structures. Okay. So to be able to use R, because if we are doing statistics, we'll be dealing with data, right? So for data, you should be in a position, if you want to use it, to be able to know how is data stored in R. It is very important. Other than that, it becomes difficult to manipulate data. So I'm going to talk about 4 types of structures, and then whenever you are faced or whenever you have a data, you can now decide that this data fits into this category or structure, so I can store it as that. Okay. So the first one is called a vector. So those that have some mathematics background who know, not really, if you have done any core maths, you know what a vector is. So a vector is just a one-dimensional array, right? What do we mean? I can get a vector of age, right? So I can say age is a vector because it's one-dimensional. Each of us over here, if we were to pass a paper around to write your age, at the end of the day, I can list them on a paper, either horizontally or what? Vertical. And that's a vector. It's one dimension. Is everybody okay with it? We can also bring a weighing machine here, put it there. We all step on it, we'll get weight, right? So when we call this person, this is the weight. Call another person, this is the weight. And this is also one dimension because we have only weight. The first person is 80 kilograms. The next person is 100 kilograms. The next person is 95. Then maybe we have PSA 145. And so forth. Okay, so this is a vector. Is everybody okay with this? Okay. So I'll move on to the next one. So we are describing them, then we come to, once you know what it is, we will now come to see how we can implemented. Okay. The next one is a matrix, right? So if you have seen a matrix is two-dimensional. It has rows and it has columns. Okay. So in R, whenever we have several variables, we can put them together to form a matrix. So that matrix will then be what? A rectangular shape. So I just talked about age and weight. So I can collect data on age and weight. So if I do that, we can list this one here, like this. So if I were to do this, we'll have weight and then age. Then maybe the first person is Amma. What is Amma's weight? Amma is the Diasa one. So and Amma is 28. Then I move on to Kweku. Kweku is 85. And Kweku's age is 35. Then I can move on to what? Maybe Abba. And Abba is 60 and 31. Is that okay? So this is what we will term as a rectangular data set. So this like. So this is like a matrix, right? It has rows, which are the individuals, and it has columns, which are what? The variables. Please, are you okay with it? Okay. So that's a matrix. Okay. Then the next one is called a data frame. So if I want to list them here, one, we have vector. Then two, we have what? Matrix. And then three, we said data frame. Now, the data frame is also rectangular. It's just like a matrix. The only difference is that the data frame can contain different data types. So if you look at this matrix, they are all numeric, right? Okay. If I were to add religion, then I'll ask Amma, what is your religion? Maybe Amma says Christian. Kweku says Muslim. And then, is it Hindu? Something like that. So now, you see, we have different data types, right? This one, we will say it is what? These are all quantitative, they are numeric, right? You count. What about this one? They are qualitative, the groupings, right? And so forth. So you see, if I combine this, a matrix cannot hold such a data set. It will turn all of it into what? Into the lowest category, or the lowest type of, or scale of measurement, which is nominal. So it will turn weight into nominal value, which is not what we are after. So a data frame is just also rectangular or just like a matrix. The added advantage of it is that it can contain what? Different data. What other than that is the same as a matrix. So it means that when we collect a data set, and we realize that these data sets are different types, you are asking them which region they come from, which political party they will vote for, okay? And then you ask the person's age. And you cannot be storing it as all a matrix, but rather as all a data frame. Is everybody okay with it? Okay. Now, let me assume that I have data on these people, right, up to here. Okay. But I went to, this is, let's say, University of Ghana, right? And then I went to KNUST. And also I got some data like that. I went to UDS, I got another data like that. These data, maybe here I only ask of even their name. Okay, so this one we have name. Then maybe age. And then I asked of political affiliation. So when I come to University of Ghana, there is nothing like that. Okay. I went to UDS. There, the students, I only ask of their age. So I just have a vector. Is that okay? So if you look at this, they are different what? Data structures. But I want to put all of them together to form data on Ghanaian universities. Then I have a colleague in Nigeria can also give me that same data. It means they cannot fit into any of the data structures we talked about. Right? So there's this one called list. We call it, so the fourth one is list. So a list is also one dimensional. It's like this. Okay. So like this. Okay. But here, I can have a vector. Okay. The next part, I may have what? Maybe a matrix. The next one, maybe it's a data frame. And even here, it can also be a list within a list. So, a list is the most complex data structure in R. And it can contain anything, right? Including itself. Yeah, so that you can use it to organize data, that, have complex structures. Any question? So a list, yes.
You mentioned that the data frames
Yeah.
can contain different
Data
data types.
types.
So, but then the matrix cannot.
The matrix will have to contain only one type. So maybe I should have started from, let me just take the opportunity to talk about data, right? So when we have data, it can be either quantitative. Maybe you can switch on the light when we finish with this one. Then. Where is it? Is it there? Okay. Quantitative and what? Qualitative. Qualitative. Okay. So here, these are the numeric ones. These are all the non-numeric ones, right? Okay. Even when we have quantitative, we can describe it as either discrete or what? Continuous. What do I mean by this? So here, I can have age, right? Age is continuous, right? Because I can have somebody who is 9 years and what? Maybe 6 months, right? And so forth. Or maybe weight. Your weight may be 85.4, right? But when I start asking you, how many children do you have? It is either 0, 1, 2. How many, what else? What discrete? Yes, so how many children do you have? 0, you don't have any, right? 1, you cannot be telling me 1.5 or 3.1. Do we have human beings with 0.0? No. Is that okay? So those are the discrete types. Then the qualitative, let's say I ask you of your religion. I ask you country of birth, region you come from, your gender, or your sex, and so forth. Those are the qualitative types. Okay. Then in statistics, we also have what we call level of measurement. I'm sure you do all this in your the introduction to statistics. Now, level of measurement. Now, when we have this, qualitative, I can talk about, I listed what? Religion. The fact that you're a Muslim doesn't mean you have a higher skill than a Christian or a Hindu and so forth. So there's no order attack. But when we come to grades, or even the university level, what level you are, there's some. So if somebody is in level 400 and somebody is in 100, we know that the level 400 has been in the university or spent more years in the university than the level 100 one. Okay. So when we have categories where there are no order attached to it, we say they are what? A nominal scale. And then when we have categories where there is order attached to it, like your level, right? Or you go to the hospital, the emergency, they have colors to indicate the severity of what? The case. So some of them you have to write. So when you are not, they will say you wait for us. So that we must attend to the one that is in danger of what die. And so all those things, they are groups. So if they were to group you, they will put you here, and so but we know that these people, they are almost getting to that, so we must attend to them. That's an order. We call it ordinal data. And then when we have the quantitative, we can now have those that are what? Ratio or what? The interval scale. They are almost the same. The only difference is that the interval scale, they don't really have a true 0 point. So for example, we say your temperature, we put the temperature here to 0. Does that mean there's no temperature? If the temperature is set to 0, there is 0, yes, there is. So if outside temperature is 0 degrees, it doesn't mean that there's no temperature. It is different from when I listed how many children do you have. 0 means if I come to your house, I will not see any child. So that's the difference. Or the psychology, they do IQ, right? If you get a mad person and you want to, any question you ask, they will give you a different answer. So at the end of the day, the person will score 0. It doesn't mean when we cut open the head, we will not see any brain, right? Yeah, so that's where we say there's no true 0 point. In other words, 0 does not mean that there's anything there. You can find something over there. So that's it. Now I come back to your question.
Yes, so I was asking that, I just want to find out if the matrix is restricted to quantitative.
Not quantitative alone. So if I have religion, country of origin, and let's say your sex, those are all categorical, so I can group them under a matrix. Yeah, just that you can't mix them. Yeah, so we cannot have quantitative and what? Quantitative in a matrix. And usually we'll be dealing with data frames because that's the easiest way to store data. So you realize that all the data sets we'll be dealing with now, most of them are stored as data frames. Is everybody okay with it? Okay. So now, please, if you have any question, please ask before we get to, you must understand the concept so that when we are doing it here, it becomes easy. So what have I done? I can use diagrams to represent it. So, what are we saying? That we have 4 different data types. If I go and collect data and my variable is 1, I can represent it as a vector. Whether it is quantitative or qualitative. Yeah. So, all we are saying is that a vector is 1 dimensional. It's like this. So you have something like that, and then you put in what? Data. Now, as soon as we start dividing this into this, we can have what? A matrix. Then we can also have another form, also data frame. But the only difference is that here our data must be what? 1 type. Either they are quantitative or what? Qualitative. But here we can have both quantitative and what? Qualitative data. And then lastly, we have what? a list. A list is also like, oh, it's just like this is a vector. So list and vector are almost the same. The only difference between a list and a vector is that the list, each space over here can contain any data structure. That's it. So we can represent what we have done in this form. Are you okay? The list and the vector. Okay, so that's what I was saying. So here, this, what is over here can be that. Can be a data of this form. So in other words, I have weight, height, maybe relation. But they are all stored in this place. When I come here, it can only be a number like maybe 12. Okay? Or it may be what? Let's say female. Which is this is categorical, this is what? Numeric. So that's the difference. But here it can be any other data structure, any of this, or even including the cell. So that's the difference. Any questions again? Okay, all right. So let's move on. Hallelujah. Yes, sir. Okay. So, oh no, I need to go. So we can switch off the light. So now we want to see some data sets in R. Okay. So let's look at question mark and then do state X77. So question mark state X77. And then run it and let's see. State X77. Please, have you all gotten it? So you see state. So it says this is a data, the name is called state. It is in what package? Data set. Remember, the one in the curly bracket is always what? The package within which whatever you are looking for is in there. So this state X77 is what? US state facts and figures. Okay. Now, what I want us to see is what type is this? So we can look at the structure. So the structure of an object is is structure. So to get the structure of the data, we use what? STR. Okay, so like that, and then we run it. So when we run it, it tells us that this is what? Num is numeric. So this data is stored, they are all numeric. The first, this 1 to 50 means it is made up of what? 50 rows. So 1, 2, 3, up to what? 50. As a matter of fact, when we take this, if we want to run this, let me put 1 to 50 here. It means you can list what? 1, 2, 3, up to what? 50. So that's it. So I can go back again and look at, so we are looking at the structure of what? State X77. So it has 50 rows. How many columns? So the columns are what comes after all the comma. That is all 8. Is that okay? So it means that this, we know that this one is of what? This form, right? But it has 50 rows. So if we were to do this, we need to do, and then the last row. Like that. So it's rectangular, right? That's why we have this. As soon as we see this, it is rectangular. So this, whatever is here is rows, and whatever is here is all column. That's it. Okay. So now we want to see what is inside these.
Sorry.
Yes.
Can you go back again there? The
1, 2. So 1 colon 50 means move instead of 1, 2, 3. You are moving up to from the beginning to the end in steps of 1. So if I switch it around and I do 50 colon 1, it means I must move from 50, 49, 48, and so forth till I get to 1. So it's a sequence. Yeah. All right. So now we also have the names. So it is telling you that you have the dim name. So 1 to 50, they are all characters, right? So we start from Alabama is the first one, Alaska is the next one, Arizona, Arkansas, and so forth. Okay. Then the columns are also the population, income. So the columns are usually the variables, right? And the rows are what? The individual. In this case, an individual is what? An individual state, not like the previous one I did. An individual is what? Maybe Ama or Kwesi, and so forth. Please, are you okay with it? So we can display the content of state we can display the content of state X77. How do we display it? You just call the name, right? And then you run it, isn't it? Yeah. So we can call it, and then we run it to see some of the, but because it's so many, 50, we won't really get. So there it is. You will see some of them. So yeah, 56. So it divides them into. So this is how it looks like. So Alabama. So there's the population of the state, the income, the illiteracy rates, and so forth. So that's how data sets are stored in that. Then there's the life expectancy, MEDA, HS grade, grad, frost, and then area. So those are the 8 variables. Is everybody okay? Good. Okay. So now we can also look at another data set. There's also a data set called anorexia. So let's look at question mark anorexia. But this one is in mass. So we're going back to help. We did help the last time. I think I used the same example. So please click on question mark anorexia. So this is what? Weight. So the data set is anorexia. It is in what package? Mass. Okay. So we can also, and it talks about the description. So now what do you see here? What is the type? What type of data do we have here? Data frame. So that is also rectangular. What are the characteristics? This is a data frame. It can contain what? Different data types. So let's see how this anorexia data is. So let's click on it. It tells us that it has 72 rows and what? 3 columns. Okay, so let's run it and see what it is. Who can tell me what is happening now? Yes. We did not load the package. Under normal circumstances, even the question mark should not even give us any help. But it is being used by other packages. Remember the Zelig and so forth, they depend on these packages. So sometimes you can get help on it, but when you want to display the content of it, you won't get it. But now we know that once we have a data set in a package and we run and it says object not found, we have not loaded the package. So what do we do to rectify this? We go to packages. What do? We look for what? Mass. And there it is. We click on it and then library that. So now I can call an eraser. So to run it, you can highlight it or you put it on what? A new line. Okay, so in this case, what have I done? I've highlighted it, so I just click on run, and this is a data set. So this is a data set on people who have eating disorder. So they were given, so the first person was given the control, which means if it is medication, there's no active ingredient. The person's weight before the intervention was 80.7. By the time they finish, the weight has reduced to what? 80.2. So in this case, they are even helping them to eat, which means this person was not. It's contrary to what the experiment was. The next person is 89.4, also reduced, even contrary to what is expected. The next one, 91, also reduced. 74, this one is eating well. 78, reduction, and so forth. So we can go on to the next one, which is the FCBT, that is cognitive. All what I'm saying is here, right? If you scroll down, it says the data, this is a data frame contains the following columns. Treat is a factor of 3 levels. I'll talk about this later on. So the control, so there are some that were not given anything at all. Then there are some that were given a cognitive behavioral treatment. That's psychology. And that one, this one is what? FT is what? Family treatment. Maybe your family will come to you. Please, we want you to eat. We don't want you to die now. So then, because of family connection, you start eating. So let's see. For those that were given cognitive behavioral treatment, the first person, there was an increase in weight, which is in line with what the program is about. The next one, 84.9, there's a slight increase. 81, this one, there's a decrease. 82, there's a decrease. 79, there's a decrease. This massive increase. This one adhered to whatever was being given, right? The next one, 94, 98. The next 76, and so forth. Okay, so we can go on and on. Then we come to the family treatment. 83, 95, okay. 83, 94, 86. So the family treatment seems to be working. Okay, so this one, later on, we will be talking about test of hypothesis, right? We will be checking whether the treatments are actually effective. If it is effective, we expect you to increase, your weight to increase. And look at the way this experiment is set. The same person is weighed before and what? After. Is everybody okay with it? Yeah. So we'll be coming back to this to be doing, but before then you would have treated this in your statistical methods. You want to answer this?
Yeah, my one is not displayed as such.
That's displayed as well. No, you are using the question mark, so highlight it without the question mark. So the question mark is bring out on the eraser. But if you want to display the data. So this may be an experiment in which they are, let's say, clinical psychologists, right? They do not give some of them, that's how experiments are conducted. Some, you just leave them like that. But because you want to let them feel that they are also part of the program, you give them something. Okay, so if it is medication, all of us are taking the same medication. However, in some people, there are no active ingredients. Usually, when you are even doing that, you don't let the doctor even know the medication the person is using. But they are boards, okay, these are clinical trials. There will be boards, and that board knows that, okay, they will randomize it. So it's blind experiment. So the doctor is administering the drugs, but I will know that the drug that this doctor administered does not contain any active ingredient. You do it in such a way that you take out buyer. So for example, if I'm a doctor and I know this person and the person comes, I know that the person is sick. I will not give the placebo or the control because of emotional attachment. So you take that one completely from the doctor. So there is a blind study. The doctor doesn't know, but because I hold the key, I know that this one does not contain anything. So because the person has come and the doctor has treated the person and given medication, they will take it religiously and also feel that that psychological aspect is taken off. Okay, so that's how these experiments are done. And in some of your projects, some of you may be, analyzing data sets like this. So our contains data sets. These are real data sets, real experiments that were conducted. So this is what a data frame. And you realize that the first column is what? Categorical data. The next two columns are what? Quantitative data. But we'll come to that. We'll do hypothesis testing. This is paired experiment. You take measurement before and then after. We can even continue. At the end of, let's say we start the first month, we take your measurement. Then 6 months, we come and take your measurement. The next one, we come and take your measurement. That is called repeated measures. Okay, so you have hypertension, medication. They need to take it continuously. So maybe you go to the house or you visit them every month and take the measurement. So at the end of the year, you have done 12 months. And you want to check whether the medication is effective. If it is effective, then it should maintain the blood pressure to the specified level. So in some cases, you realize I need to go up and it goes down and so forth. And then you check it. But in each individual, you have taken 12 measurements. So we spend a bit of time here because as we are doing, we are also explaining the statistical concept we need in doing this. What time do we have to close? 6:20. Okay, so somebody will come and take me off. Okay, so you want to take a break or I should continue? Okay, so I've shown data frame and then matrix. So each variable is a vector, right? Which means when I have a vector, I can combine them to form what? A matrix or a data frame. And how do you construct them? Well, for a data frame, we use data.frame. So if I have, let's say I've collected, we can do a simple example where we say that we have weight, let's say weight. So if I want to create weight data, let's say I ask 5 people of their weight. This is how we do it. So I write weight and then I do assignment statement. Okay, then I use C. C is called combine, a small letter C, right? So that's the combine function, which is that every object I have in there, I'm putting them together to form that vector we have over there. So the first person, I think I wrote something there. So the first person is 145, The next person is, let's say, 80. The next person is 78. The next person is 95 kilos. And the last person is 75. So I can have something like this. Okay. Now, if I run this, what will happen? I'll have weight stored in what? Environment. And weight is what? Numeric, right? How many observations? 5 people. That's why you have 1 to what? 5, and it's a vector. Okay. Then let's talk about their age. So similarly, we have C. So the first person is 34 years. The next person is 28. The next person is 56. The next person is 40. And then the last person is 38, something like that. Okay, and then I run it. Okay. So then age is also numeric. Remember I said the data is rectangular, so I cannot be combining data in which one has 4 values, the other has what? 5. But if they are 5, if the 4 and 5, it will not be rectangular. But if it is 5 and 5, it will be rectangular. Okay. So if I want to create my data, I can now say this is, I can have a matrix or I can have a data frame. We usually will deal with data frame. So let's create a data frame, our own data frame. It's data.frame, and I can just collect weight and age, put them together. There we have it. Okay. And there we have. So you see now we have all rectangular data, right? And when you display it, you have what? Weight as the first column, age as the next column. So we can create our own data. So if you have the data, you can create it. The next thing we are going to do when we meet tomorrow, right? It's tomorrow. Yes. So when we meet, please get, if you have any data at your workplace that you need to analyze it, just get it in Excel. When we come, we will see how we can import data from Excel into our. When we import it from Excel, it will come as a data frame. Yeah, so we'll do that tomorrow. Okay. That's a data frame. We can create a matrix if we want to create a matrix. Because this one, they are all quantitative. We just use C bind. So if you want a matrix, what you use is that, let's say, I call it math.data. So in that case, I'll just use C bind. That is column bind. So it means I can also have a row bind, which is what? R bind. So if I do it this way, I'm going to get it what? As this, just like the data frame. But for the matrix, I can also do it in such a way that I have it in row. So in that case, I'll just, instead of column, I'm going to do R bind, which is row bind. So take them, the first one will be weight, the next one is column. Okay, so we can add either attaching them column wise, or we can also attach them row wise. So as I said, tomorrow we will try and read data from Excel and also from test file. And even when it is online, we can also read data when it is online. I can just read the same way we install packages. When we have a data online, we can also read it. And we'll get some data online as well and read it. Okay. So let me leave you now so you can get to do your next lecture. Okay, so